Okay, starting Unit 2, Objective 1, Analyzing Piecewise Defined Functions. A couple of things before we start this set of notes. There's two things I want to point out. One, your page does not have the lines drawn. I did plot the points for you to draw your graphs on all these graphs. So just pause the video at the beginning of each problem and draw that graph using the points that I plotted for you. And then the second thing on the second page, we're not going to be actually writing the piecewise functions. We did that in Unit 1. We're not going to repeat it here. All right, so let's go ahead and start this set of notes here. So we're going to be looking at different parts of our equations and graphs now. This first section is actually a bit easier than what we did in Unit 1. So like it says, within a piecewise function, you'll find the graph to behave in different ways. Mainly, our graph can be increasing, decreasing, or constant. Okay, so what's it going to look like if it's increasing? Well, it might be something like a line with an uphill slope. That would be an example of when it's increasing. It might be like the right half of a parabola that's going up, so it could be curving up like that, or it could be curving up the other way too. But basically, if we're going from left to right and our y values are getting bigger, getting taller, then that's considered increasing. Decreasing would be just the opposite. It could be a line with a downhill slope. It could be like the left half of a parabola that's opening up, or it can be any other curve that's going down from left to right. Okay, so those would be some examples of what a decreasing function might look like. And then if our function is constant, well, there's only one way it can be constant. It's if our y values are not changing, so just like a horizontal line. Okay, so that's what we're going to be looking for in the graph when we're looking for these things. When we are talking about intervals on a graph, and hopefully you got this from last unit, but we always want to define our intervals in relation to our x values, never our y values. So if I say, in the interval from -1 to +5, I mean x values of -1 to +5, not the y values. Okay, and then also always define the intervals as open. Okay, because if I want to know what's my graph doing on a certain interval, well, I want to know, from -1 to 5, what's it doing, not at a specific point. So then we always want it open because we're not including any specific points, which means we're going to use parentheses, not brackets. Okay. All right, let's take a look at our first example. It says state the open intervals on which our function is increasing. So then where is our function getting bigger? In other words, as x gets bigger, where is y getting bigger? Well, that'd be this first part of our function here on the left, because it goes down to -infinity. If I'm going from left to right, it's going up, 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 up until it gets to here, and then it changes. Okay, so it's increasing from, well, all the way from -infinity up to what point? Well, again, we want to look at the x value of +1. So from -infinity to 1, my function is increasing. Is it increasing anywhere else? No, so then that's the answer for part 1. Part 2, state the open intervals on which our function is decreasing. So where is it decreasing? So let's see, here it's increasing, then it's constant, and then here it's decreasing. So it's decreasing from, again, from what x value to what x value? So we got x is 1, 2, 3, 4. So from x is 4 to x is 5, it's decreasing. So just from x values of 4 to 5, that's where my function is decreasing. And the next, where's my function constant? Where is it horizontal? Okay, well, we got a little chunk right here that's horizontal from an x value of 1 to an x value of 4. So it's constant from 1 to 4. And then is it constant anywhere else? Yeah, so then we want to union that like we would with a domain or a range if there was, multiple parts of that. And then where else is it constant? Well, from here all the way over. So from our x value of 5 all the way to +infinity. Okay, so if there's more than one piece of your graph that is constant or increasing or decreasing, you're going to have to union those parts together. Okay. Next, we want to state the domain and range using interval notation. So this is something that we've hopefully are used to by now. What's the domain of this function? Okay, well, it goes to the left forever. It goes to the right forever. So then my domain would be all reals, which we would write from -infinity to +infinity. Okay, and then what about my range? Okay, well, what's my lowest y value? Well, this thing goes down forever, so it goes to -infinity. And what's my highest y value? Well, it peaks up here in this little constant spot here at a y value of 3. So it goes from -infinity to 3. Now with the domain and range, we might want to use brackets. Can y actually equal 3? Sure, it's 3 at a bunch of places right in here. So then we're going to put brackets around the 3 because we are including 3. Y actually can equal 3. Okay. All right, next, talking about something a little different here. It says a relative maximum. So maximum and minimums we learned about last year. So it's very similar here. A relative maximum occurs when you see and then one word to describe it would be like a peak. Okay, and what might that look like? Well, it could be like the vertex of an absolute value function that's opening down, or the vertex of a parabola that's opening down. Okay, so when we see that high point, that maximum, we call that a relative maximum. Okay. A relative minimum occurs when you see and another word to describe that might be a valley. Okay, so a valley would be like an absolute value function opening up or a parabola opening up. So when we see that, change in direction there, that's when we're going to get a relative maximum or relative minimum. Okay, so then in general for these, when does this happen? Well, when our slope goes from, so right this way, slope goes from positive to negative, or from negative to positive. So we can kind of say it that way. Okay, so when our slope changes from positive to negative, or when it changes from negative to positive, we're going to get one of these situations, and that's going to give us a relative maximum or a relative minimum. Okay. All right, so let's apply this stuff here. Rule, a change in direction must occur for there to be a relative max or relative minimum. In other words, it has to go from increasing to decreasing or vice versa. It can't have, it can't go from increasing to constant to decreasing. This does not provide us with a relative maximum. Okay. All right. All right, so analyze the graph and answer the following. First of all, are open intervals where our function is increasing. Where does that take place? So where is this function increasing? Well, it starts off increasing from this x value to that x value, which is from -7 to -4. Okay, is that the only place that it's increasing? So let's see, it's increasing and then decreasing and then increasing again from an x value of -1 to an x value of +2. So then we want to union that with -1 to 2. And then are those the only two places that it's increasing? So increasing, decreasing, increasing, decreasing, and then increasing a third time from an x value of +3 to +5. So we got to union that with another section from +3 to +5. Okay, and then those are the only three places where it's increasing. So that part is done. Next, where's our function decreasing? So it starts off increasing, then it's decreasing from here to here, which is from an x value of -4 to an x value of -1. So it's going from -4 to -1. Where else is it decreasing? Well, this little section right here, from +2 to +3. So we got to union this with +2 and +3. Is it decreasing anywhere else? Yeah, from here over. So we got to union that with, this is an x value of 5, and when does it stop decreasing? Well, never, since this is an arrow, so it keeps going down. So from 5 to infinity, it's decreasing the rest of the time. Okay. All right, next part, where are the open intervals where our function is constant? So where do we see a horizontal line? Nowhere. Okay, and that's fine. That just means there are none. Or you can put the no solution symbol if you want to, the circle with a little slash through it. Okay, because there's no areas on this function where it's constant. Okay, state the domain and the range. So what is our domain? Okay, so what do our x values go from? We always want to start with the smallest x value, which is over here at -7. Can x actually equal -7? Yes, it can for this one, so then we want to use brackets. And then it goes to what? So are there any holes in my graph? No. When does it stop going to the right? Well, never. So it goes from -7 to infinity. Okay. So there's my domain, my range. Well, what's my smallest y value? Now be careful, because if you're looking for the lowest point on the graph, it's here at -1. But since this is an arrow, well, it keeps going down forever all the way to -infinity. So y goes all the way down to -infinity. And up to what point? What's the highest point on my graph? So here there's no arrows to worry about. The highest point on my graph is up here at positive 5. And then since y can actually equal positive 5, we want brackets around that. And then we're done with the domain and range. Okay? All right, next, new part here. Identify the coordinates of any relative minimums. So where do we see, a valley? Oops, sorry. A valley, something like this or this. Okay, well, we've got one here, and we want the coordinates of that point, so negative 1, 0. So we can say we have a min at negative 1, 0. Okay, and again, this isn't an interval, this is just listing the point now. And where else? Do we have any other relative minimums, any other low points? Would this be a relative minimum? Well, no, because there's no change in direction, that's just a low point. Okay, again, we have to go from decreasing to increasing or vice versa. Okay, here we go from decreasing to increasing, so there's another relative minimum there at 1, 2, 3, 1. And again, since these are not intervals, these are points, I'm just putting a comma between them, not the union symbol. Okay, because it's just this point, comma, this point as well. Are there any other relative minimums? No. Okay, identify the coordinates of any relative maximums. Okay, now you don't have to put the max at part. I'm just going to go ahead and put it there. We have a relative max at where? Okay, so where do we go from increasing to decreasing? Well, here's one point at negative 1, 2, 3, 4, 2. Do we have any other relative maximums? Sure, again, we're looking for these peaks. Where do we have those? Okay, well, we've got another one right here at 2, 2. And one more up here at 5, 5. Yeah. And then those are all our relative minimums and maximums. So that's the first page of the notes.